Okay, great. Well, thank you all for coming to our session on wearable tech. This is Kay, and Kay will be the first one to present of the three of us. And Kay is an artist, designer, and creative technologist based in Brooklyn, New York. And they have been working as a freelance costume designer for the nightlife since 2018. And their work has been on stage at Bonaro, House of Yes, Bushwig, and on Watch Packin for RuPaul's Drag Race season 16. I'm very excited to hear your presentation.
Thank you. Like Rehana said, my name is Kay. I bet you all didn't think you were going to see a full butt this early in the morning. I'm a New York-based designer and artist of many types. I'm a self-taught costume designer, and I've been making costumes for nightlife in New York since 2018. I get to make the most incredibly gorgeous, exciting, and creative costume pieces for mostly queer clients. And there are so many things I love about doing this work. It's also a client base that is always looking for new and magical ways to engage audiences and is a growing space that's looking to integrate aesthetically focused wearable technology, which is really exciting for me. These two performers, this is two different costumes that I made. Neither of these have tech in them, but the dress is worn by Rara Darling for their show Snack Theater, and the other cowboy chap set is worn by God Complex. I think this is a Bonnaroo photo. Are we good? Volume down. Sorry, this is a problem I have a lot because I'm used to hosting drag shows. I like really yell into the mic because I'm used to talking over loud bars. So I am also a drag performer, and in 2021, I started experimenting with integrating electronics into costumes for my performances with this wig. This is version 1. It is a little wonky, but it was my first attempt at physical computing kind of at all. I believe there was an Arduino Uno. I can't remember how many servos are in this, but I tried to use like an old school puppet mechanism to make the eyes rotate with like a medium amount of success. It sort of did it. I did do a second version of this wig a couple months later, which is much better looking. This had an Arduino Uno, I think 7 micro servos, and it was based on Nilheim Mechatronics animatronic eye designs. And Will Cogley, who runs that Nilheim Mechatronics, was so kind and actually worked with me and my friend to help us tweak the 3D models for this eye print because his obviously was set up for 2 eyes and we wanted to add a third that blinked in unison with the other 2. So shortly after that, I decided to attend the Interactive Telecommunications Program at NYU, also known as ITP, which for those of you who are not familiar is NYU's weird integrated tech and art program. During this time, I started to be asked by more performers for costumes that integrated electronics into them. So this green one here was for a mandatory meeting for Drag Race season 16. It didn't make it to air, but it did make it to some of the ancillary costume behind the scenes stuff, which is what this clip is from. This has 6 of Adafruit's mini squirrel cage fans in it. The idea was that it would blow Amanda's hair around when she wore it. That's why the shoulders are massive on it. If you need to know anything about small footprint fans and how much power they have, I now know quite a lot. The second one here is for Cara Mia Antoinette for the Miss Coney Island pageant this past fall. This was done in collaboration with a bunch of artists and costume designers, so I didn't actually make the dress here. But the ride carriage on the bottom I handled, and that's a replica of a haunted house ride that has been at Coney Island for a really long time. So the project that I'm going to focus on today was part of my graduate thesis last year, which was an exploration of PCBs as wearable art. This is a flexible LED grid dress made out of PCBs that I designed, which are linked together using a jewelry making technique. This creates an LED grid that's much more flexible than many of the other ones available on the market. So unlike existing models, there's no backing material that the PCBs are mounted to, like fabric or plastic. It's freestanding, and the flexibility comes from the way that the PCBs are connected, which is using a jewelry making technique. as I was working on this project, I set myself 3 major goals, which were to incorporate high fashion aesthetics into wearable electronics, not to try to hide or disguise the hardware and electrical components, but rather to make them a showcase of the piece itself, and then to utilize techniques not traditionally considered in electrical engineering in order to solve problems. So acknowledging the value in techniques often labeled as like crafty and that are minimized against the idea of tech. So in this case, jewelry making was a big one. So these are some of the huge inspirations behind this project. The first image there, the Guopei 2019 piece, I'm going to show a zoomed in image of in a moment on the next slide, but that was really the one that gave me the initial concept for this dress. So it's hard to tell in this image, but that's entirely made out of linked together rhinestones. And I sort of looked at that and went like, oh, if you can link rhinestones in that way, why not LEDs? The second image is for Givenchy 1995's collection. I believe Alexander McQueen actually designed this before he had his own brand. And again, this is really a collection that showcased tech as art. It's in the early 90s. It was, I think, a time period where people were really interested in the aesthetics of like circuitry and LEDs on its own. And that also coincided with a lot of like consumer products that were having the clear electronics housing at that time. So phones and I'm sure a lot of you remember the early iMacs, stuff like that, that you could look into and actually see all of the inner workings of the electronics. And the last image here, I actually didn't find the real name and inspiration of this until I was pretty far into the project, but clearly was sort of rattling around in my head. These are really iconic 60s, 70s fashion, Paco Rabien's 12 Unwearable Dresses, which was a series of dresses made out of things like plastic and metal that were linked together using chainmail techniques. Again, this became really iconic, like 60s and 70s, like high disco sci-fi fashion look. And there's movies like Barbarella and a lot of other stuff from the time that pulled from this aesthetic. And actually, if you go to the National Museum here in Edinburgh, there is one of those dresses there, and I got to see it in person on Friday, so I was very excited about that. So this is what I was talking about with the close-ups of how the rhinestone fabric is constructed. So this is a close-up of the Guopei dress, the colored one there. And then just, that's probably a much higher end version of this silver fabric, but I think this demos pretty nicely what I'm talking about, which is rhinestones, rigid, obviously don't flex on their own, but linked together with enough space in between and with the correct linkages becomes very flexible, almost like a fabric, even though everything in it is rigid. And this is just an even closer up photo of like what the housing for that looks like. And as I said before, I was sort of thinking about the way that the rhinestones connected and thinking to myself, like, why not do that with LEDs? Essentially, I figured the exact same format could work. I also decided at this point, partially because of my commitment to like using electronics as an aesthetic in and of themselves, that I wanted to use this larger style of LED package. So the kind of LEDs that you would plug into a breadboard as opposed to the surface mount addressable ones. This did make my life slightly more complicated because the LEDs were not addressable in and of themselves. I had to use some additional hardware to make that happen. So now getting into the process of the dress design itself. I tried a few different options for the backing of the LEDs, including 3D prints and laser cut supports. I eventually landed on using PCBs for both support and functionality. I was taking a class in PCB design at the same time that I was figuring out the fabrication for this project, and this is the point where I fell in love with PCB design as a process. So the first image is laser cut mirror acrylic, and then some of the other PCB iterations that I created throughout the process. Anyone who's familiar with PCBs will note that that first circular one is absolute garbage. I don't know what I did to the file. That was the first one I ever made, and it is a totally useless piece of copper. But I do think it's funny to show. So this sample was a huge turning point for me, and this is actually a really good demonstration of just how flexible the whole dress is, because the final one is as flexible as this little swatch. So I figured out the level of flexibility I could achieve with the chainmail and jewelry techniques and the PCBs that I made. I also, at this point, fell in love with the raw copper finish of the homemade PCBs. So when you make them DIY using like a milling machine, you use copper clad board that isn't necessarily covered in protective coating. You can add that later, but it isn't inherently part of it. So I had originally planned to have them coated once I finished prototyping the boards, but at this point, I just decided that I liked that finish and wanted to keep it. So this was my first prototype. It was a proof of concept for me that the combination of tech worked, but I needed to work on the consistency of the wiring and materials used in the construction. I used solid core wire to assemble all the connections on this, which had the tendency to both break if you manipulated it too much, and made the entire thing really weirdly rigid, which was not what I was going for, but was very interesting. This would stand up on its own. You could sculpt with it. I think it would be a really interesting sculpting material, but it didn't have the curve fitting flexibility that I was looking for something wearable. So moving on from that initial prototype, I needed to finesse the connections. So I tried a couple different methods connecting the PCBs together. And this is the stuff that I was really excited to dive into with the group here at Open Hardware. So this sample was done actually using conductive chain. So that's carrying the signal itself. You can see in the clip that it's pretty stroby, which is why I ended up not going with this, basically because the links all have to be perfectly taut together at all points to get anything to light up. And because of the flexibility, that's just not always the case. You're like slightly losing the connection on power or ground at any given point. But it is really interesting. And then this was another one I did using conductive thread insulated with glass beads. This worked pretty well, actually better than using the chain as conductive material itself, but I think I had some issues with consistency. You can see I am getting a little bit of a flicker. From what I've heard also, I haven't actually worked with conductive thread over like huge scales, but it's resistive enough that you start to lose electricity over longer distances. So for the scale of object that I was creating, I didn't think that this was ultimately going to be a good fit. However, I think it would be super interesting for a smaller project, and I do think it makes such a beautiful alternative to using straight up wire. And I do want to just credit this. This was inspired by a tutorial on the Kobakant website, which is Mika Satomi and Hannah Perner-Wilson's e-textile collective. I have a link to that at the end of this presentation. So I also explored some solderless options for attaching everything together. I tested using both crimp beads and wire guards. Wire guards are the curved one there. Crimped beads are just the little metal tube. Wire guards are used to protect thread for beaded jewelry where it might rub against metal connectors. So to use the wire guard, I actually created, and the crimp bead, I created a double hole pad on the PCB. So I designed my own part, and then I looped the wire through and crimped it in place. Ultimately, when I was testing strength, soldering was stronger, so that's what I went with. Again, given the scale of the project, I was working with a couple hundred PCBs. I couldn't have one break a connection and fall apart. But I think that this would work super well for smaller projects, and also is really interesting for creators who don't have access to soldering or maybe are intimidated by soldering. I think this technique has a lot of potential. This is just a close-up photo of the wire that I ended up using as opposed to, the solid core or the beaded threaded stuff. It's clear speaker wire. It's very thin. It again tied into my goal of keeping everything like transparent and highlighted. I really liked that you could see literally straight through the wire coating to see the copper and silver inside. So the belt of the dress contains the brain of the grid, which is an Arduino Uno, a 7-volt battery, and 2 HTK 1633 LED controllers, which are breakout boards created by Adafruit. And they basically use multiplexing to make all the LEDs addressable. Adafruit has a library that's pre-written for graphics, so it made it very easy for me to put in text and very simple images on the grid. I programmed using that library. This is just some more close-ups of my model Logan Lonfair wearing it. And this is a little demo video. which there is like some music on this, but it's not important. I also think this is nice because again, you can see just how flexible, oh, it's so bright in here that it is a little hard to see this. But you can see just how flexible the material ultimately was. I will also say the strobing effect is because the refresh rate of the LEDs was the same as the camera. In real life, it doesn't strobe like that, but recorded, it looks like it does. And also on cell phones, it doesn't strobe like that. I think our camera was just a little too nice. There were a couple of other PCB art pieces that were part of this entire collection, which I didn't want to dive into today because I don't think they were as interesting. But that's some of the other stuff that you're seeing. So I'll just stay here for a minute. If you talk to me after or email me, I'm more than happy to send you the technical details here, but this is the full list of software, materials, equipment that I used, some blog posts that I made that get into all of this with more detail, as well as some of the essential resources that Mike, oh, it's back. I might have just lost connection for a moment. I'm not sure what happened. But this just has a lot of the resources that were essential for me for working on this project. These are additional credits for all of the models and photographers who contributed to this presentation, as well as some of the work by to finish. I'm almost done. Testing. Hello. I'm so close to finishing. Okay, I basically just have one more slide. So thank you. Please stay in touch. You can see my full portfolio at my website. Email me. Please feel free to reach out if you want any of these slides or resources. I'm more than happy to share. Thank you so much, Open Hardware. I'm not sure what's up with the mic.
Right, hello, everyone. For this next portion, I will be introducing Rehana. Rehana is a designer of all sorts. In education, she designs learning experiences about AI, and in the wearable technology world, she designs couture dresses integrated with electronics and digital fabrication techniques, all with open sorcery at the heart at what she does.
Hello, everyone. Thank you all for coming. Today, I'll be talking about how to combine technology, craft, and innovation in wearable art. Oh, I forgot that. It's my signature when I start presentations to make them twirl. My name is Rehana. I am an educator. I work in AI. I work on AI education resources. I was a coding instructor for many, many years, and I taught robotics. We made robots out of trash and potatoes and carrots. If you're interested, potatoes make very bad wheels for robots, but carrots and parsnips, on the other hand, they're excellent, excellent wheels. I also call myself a creative technologist, which I know is a kind of a all-encompassing term, but I work in textiles. I've been sewing for many, many, many years, since I was a child, actually. Learned it from my grandmother and my mother. So I have a very vast background in tailoring and sewing. And then I've also been dabbling in the conductive embroidery kind of space, e-textiles. I love everything about e-textiles. And I also went to Harvard and MIT 2 years ago, where I also taught about Pokemon and game theory, as you can see on the slide. But most importantly, I was there to learn about digital fabrication and about education, how we can teach these skills to empower all generations and all people of all sorts of walks of life. So I mentioned a little bit earlier that I have a vast background in sewing, so I've been making dresses and gowns for a very long time. This dress actually took me many hours of hand painting. So I hand painted this dress made out of scuba fabric, so what they make scuba suits out of. And then I combined glitter with glue, and that makes the perfect potion to actually paint on dresses or on scuba fabric in general. I also I embroidered a little bit, and it has electronics embedded in it. It's an image that I embroidered from the Southern Ring Nebula. It's on a 16-inch embroidery hoop, and it has multiple LEDs that you can't see here, unfortunately, but you can take my word for it, powered by a Circuit Playground Express and that twinkle in random order. And then I also designed PCBs when I was at MIT. So I took a crash course in PCB design and digital fabrication in general, where I made this Charlie Plexed PCB that lights up, so it's a sewable PCB. And I did that during a class called How to Make Almost Anything. And you might have heard of Fab Academy, and Fab Academy is basically the same class that they teach at MIT, but the one that I took is taught in person in the autumn-winter duration, and then Fab Academy is kind of this open source available to anyone who has access to a makerspace to come and learn about digital fabrication. So I figured, how about I take all of these skills that I've learned in dressmaking, embroidery, PCB design, and I make something that is a blooming dress. And there's also sound on this, but it's not important. And the idea, so this is the blooming dress 1.0, and the idea of this dress was that you figure out how to bend leaves. So I wanted to create something blooming, right? So I made a few prototypes with just foam, and I figured that if you put a string through the top, the center, and the bottom, and you pull it, you get this motion of opening and closing flowers and petals. And if you use fishing line wire, that's more durable than thread, and it causes less friction because it's much smoother. And if you add a 3D printed, flexible 3D printed channel that you can pull those fishing line wires through, and you add a servo that's way too big and way too strong, and you create your own PCB that powers the whole lot. If you then go on to create your own corset, sew it all together, make a bunch of flowers, and put it all together, that's when you get the blooming dress. Here is another again, which I think we don't need. So it worked. Sorry. And it worked, but only worked for about 20 minutes. And that's kind of the backstory that you don't often get to hear when you see projects like these on the internet. So the blooming dress was actually featured on several websites for its technique, and I do think that it used a few novel techniques to work with textiles and fabrics and with electronics and technology, but it wasn't very durable. And the problem with it was that the flowers needed a lot more power than I anticipated to open and close. And then the pulling of the wire also caused too much friction. So the servo ended up twisting around itself. I had to hold it down or pin it down. And that's not really wearable. You can't wear something with pins in your body. And it needed also much more power than I had anticipated. And I didn't have much time to research power sources and to look at ways I could power it properly. But the servo was also way too powerful. I didn't need that servo. So comes the Blooming Dress 2.0. And the Blooming Dress 2.0 is supposed to be more durable, more wearable as well, also open source, just like the last one, because I documented that whole project. Is on my website. should have the appropriate power source, and it draws from the latest wearable tech developments. Because I don't know if you've been under a rock for the past few years or last year, but if you've seen this dress, it kind of blew my world. Because this dress, worn by Mona Patel last year at the Met Gala, has a kinetic feature where all these butterflies, they move. And that kind of changed the game because it's not one single thing that moves, it's a whole bunch of butterflies that move all in synchrony. It seems to be very wearable, and it seems to have survived the Met Gala red carpet, so it should probably be pretty good. And so I started looking into artists who've been doing some stuff with kinetic fashion and kinetic wearables and wearable technology in general. And Casey Curran is kind of the godfather when it comes to this. So Casey Curran, I've linked his Instagram page, and one of his projects uses kinetic ways of enabling fabrics to move, and he makes huge installations and tiny installations, and they're super delicate and they're beautiful. And I highly recommend you check out his work. But then you also have Lisa Jiang, who used to work for Iris van Herpen, and she makes these also beautiful kinetic wearable dresses that are powered by servos. She dip dyes them by hand, and it's like a very long process. And she was also the one behind also Mona Patel's Met Gala dress this year with a robotic spine. And I thought I had a video there, but the robotic spine with where all the individual pieces, they move. Then comes to open source. So these people have pretty close source projects for all valid reasons, right? And so if you want to start out in this space, there are very limited resources if you want to figure out how to embed electronics, or in this way, servos in your garments. But thankfully, and I was at this open source hardware summit 2 years ago in New York, and we had two professors from the Social Body Lab give a presentation about their kinetic wearables toolkit. And at the time it was amazing because I just finished that project and I thought, oh my, if I only knew about this toolkit and about the ways that they recommended you use servos with fabric. So I watched that video, ended up looking at a few ways that they use servos in their garments and how they attach them. But then I also started looking, on YouTube and on social media. I looked for kinetic fashion hashtags on Instagram, and you get all these beautiful, beautiful projects. I would like to give a special shout out to this person, Hueto Official on YouTube, that I found very randomly, who also uses kinetic wearables and servo-powered wings, kind of like angel wings, then in very strange ways. But again, it's not documented. So all these projects, they're not documented. And if you wanted to go and do your own thing, there isn't really a way to do that because the barrier to entry is pretty high. So we need more open sourced wearable projects is what I'm trying to argue for here. And so that kind of inspired me to create this new dress, which is the Blooming Dress 2.0. And the design choices that went into this dress where that it still uses the fishing line wire because it's still very durable. I should use a flexible spine to mimic the midrib in a leaf. So if you look at any kind of leaf, any kind of petal, leaf, petals don't have it, but in leaf you have this midrib, and that makes it, and if you mimic that and you create something that is a little bit flexible, then you can mimic that movement, opening and closing in a very smooth way. And then I also decided to use organza as a very lightweight option for the leaves. So all these leaves over here, they all use organza because it's very light, doesn't weigh a lot. And that also means that whatever I'm powering up or whatever mechanism I'm using to power up the flower isn't weighed down by the weight of the fabric. And then finally, uses off-the-shelf components. I unfortunately did not have access to an MIT makerspace to design my own PCB and all of that, or the time. So I used very off-the-shelf components to make it. So I started off with making the midrib spine, the piece that makes everything bend. And so I tried making several options. The option on the right, I try this so you don't have to, because obviously this is a very stupid way of doing it. If you thread if you thread through the TPU, that's too much friction and it's almost impossible to open and close it. But the option on the left, where you have these little hooks where the thread is going through, that bends very easily. And that kind of was the first discovery that I made in, if you want to make something bend, use hooks and use something very flexible and thread the thread through the hooks. And then I started to prototype, because we all know if you want to make something work and you have an idea in your head, you prototype, you put it in reality as fast as you can. So I did that together with my cat, who was observing me very closely throughout this whole project. And he probably has a very good understanding of how to do wearable technology projects too now. And that, so I printed a few of these, just got normal thread. I didn't have fishing line wire. I hooked it up to Arduino Uno, and you get this kind of like octopus movement, and they also were too long, so they got stuck into each other. But the idea worked. And so the idea is that you have this rotating disc powered by a servo that has a kind of like a disc with a bearing attached to it. And then you loop all the threads through that. And then once it moves, it will pull and retract some of the other tentacles. So the components that I used for this were an Adafruit Itsy Bitsy, a Tower Pro servo that is like a continuous servo. I use a LiPo battery that is a 3.7 volt battery. I use a power boost because the servo that I used requires 5 volts, and the battery that I have is 3.7 volts. So you need a power booster to kind of give enough and supply enough power to the servo to properly work. And then I also used the Duraflex C fishing line wire. I got this from Decathlon if you're in the UK, or you can get this anywhere. But I got one that holds up to 13 kg, and I figured that should be enough. And I could also use it for fishing if I decide to go fishing at some random point in my life. So I 3D printed those the spines. I printed them at 2 millimeter. I printed 2 of these spines at 2 millimeter so that they're extra thick, and they're the ones here at the top. I know they're a bit bended now, but that's because the thread is pulling them. But I had 2 at 2 millimeter because they needed extra thickness to stay where they are, and the rest are at 1 millimeter because you don't need that much strength in them. And then the hooks that I printed, they go through the slots to thread the fishing line wire through them as well. Then I printed this disc. It's regular PLA, it just modeled after. So it just needs to have the insertion from the servo, and then I used just 2 screws to attach it to the plate. I printed at 2.9 millimeter because it needs to be also pretty solid to provide a very strong foundation for the leaves. And then I printed and attached a very flat, thin disc that I printed at 1.5 millimeters to the servo. And the key here is that the screw in the middle needs to be very flat, because otherwise you're going to trap the threads in that screw, and then you're going to have something very very unfortunate happening, which is the lines snapping. I also don't know if you can see this, but I'm holding the screw in a very wrong position. That's because I remember this picture of this guy trying to solder, and that was obviously not correct. So then I created a very small component. It's tiny, tiny, but it has little holes around it. And I attached it to a bearing through the disc, and I attached it to the horn. So you would basically sandwich the horn between the servo at the bottom, you attach the horn, you attach the disc, and then you attach the bearing through the horn. And this is basically where the fishing line wire is going to be threaded through. What then ensues is just lots of cutting and sewing fabric. So I have a time lapse of all the sewing. So I I made all these paddles with the help of my sister and my niece, and I sewed them all to these spines. It was a very painstaking process because you need to fold them in a way and then sew them onto the spine and create them and create this kind of like flow with all the colors that go that blend into each other. And then the finished product is this. And so I attached those to the disc. And the servo goes in the middle as a refresher. Then I had this corset lying around that I made a few years ago. I used to make lots of them because they go really well under garments and under dresses especially if they're heavy. You need something to hold it in place and to provide that structure to keep everything in place. And so you need, if you wanted to do something like this as well, is to have a very strong, solid base as well. And because you have these, the lines, like the metal wiring that goes through the corset that holds everything in place and that prevents things from bending. So that was almost like a whole day of sewing and trying to tailor and drape this. I got velvet, by the way, and I draped this against my mannequin, which I also brought with me. And it basically, you pin things in, you make it the shape you want, and then you use just any kind of thread to mark the pieces that you want to sew and the pieces that you want to sew together. And also like the darts and where the waist is and all of that. And so I used just a simple draping technique for that. Did I skip one? No. And then towards the final steps, I printed this kind of like case for the servo to hold the servo in place and to sew it onto the dress. So it's basically one, it becomes one with the dress. But I didn't just attach it and sew it to the dress, but also to the corset, which is inside the dress. Then I printed something else to hold the electronics and the LiPo battery, and I also attached that to the dress, and then I wired it up. A very fun fact is I didn't have access to a soldering iron. I don't have one at home, so I did that yesterday here. And so I brought my components and I just soldered a few connections. It wasn't major, and it would have worked without it too. So I have the servo that I attached to the Itsy Bitsy. I have the power booster that I connected to the Itsy Bitsy, and then the power booster gets connected to the LiPo. This is the finished product, and then I just put them in the little encasing. And then I have a video, but I will probably not play it if the dress works. So I'm gonna just try to connect this, and if it doesn't work, I will play the video. So hopefully what you're seeing right now is the disc moving, is being powered by the power booster and the LiPo battery, and all the tentacles or all the spines are pulled one by one, and you get this kind of like rotating, flowing motion. Now, a few people asked me if there was a story behind this. I did not have time to think about a story behind this, so you can fill in the gaps yourself. But it kind of looks like a jellyfish and like a sea creature from out of space, maybe even. And so this will hopefully go on for a very long time. And here is, in case it didn't work, but it works. I think that's it. So I did tell you at the beginning that we do have a lack of documented wearable technology pieces and projects that are open sourced. So I recognize that, and I have a write-up coming up very soon, and I'll publish it somewhere. But if you're interested, you should definitely keep in touch. And you can keep in touch with me on LinkedIn. Here's my email. Thank you very much. And yeah, thank you.
Makivic.
That's why I was checking.
Okay, and I am so happy to present the last of our trio. Julia Makivic specializes in designing alternative controller video games, combining hardware and sensors to create custom gaming interfaces. Her games explore what it means to have an emotional exchange with a computational system and how our emotions are mediated by technology. She is currently a lecturer in creative electronic engineering at Royal Holloway, University of London. Give it up for Julia.
Hello, everyone. All right, thank you very much. So yeah, my name is Julia Makivic, and I will be giving a presentation on my ventures into designing wearable play. So a little bit about me. I'm primarily a designer of alternative controller video games. So some of you in this crowd might know what that is, but for the others, it is basically designing gaming interfaces that don't have traditional gaming inputs. So games that use something that is not something like a keyboard or a mouse or a typical joystick, or if they do use those components, they use them in very non-standard ways. So oftentimes designers of alternative controller video games will put together custom interfaces using hardware and microcontrollers and other found materials. And that's kind of what my practice is centered on. So I designed these interfaces that have an accompanying story with them that aligns with the world of the game that I am making. In addition to that, I've got a little bit of a background in IoT. I worked for an IoT startup for a bit and other areas within the tech industry. I got my BA in Media Arts and Sciences from Wellesley College in the States. I was raised in the Boston area, and I'm currently based in London. But the Media Arts and Sciences degree kind of exposed me to how coding can be used for creative purposes. And when I went to London at Goldsmiths, I finally got to study physical computing. And that really opened up a whole world for me. And currently, I am a lecturer in creative electronic engineering at Royal Holloway. So a little bit about my practice on alternative controller video games. It centers heavily on tactility and texture. I pay a lot of attention to the particular materials that I'm working with and how they align with the type of story that I am trying to tell. On top of that, I think about what kind of interactivity best applies to those sort of materials, or what sort of interactive elements best align with the sort of world that I'm trying to create. A lot of my games have a very heavy narrative component, so through play you do experience some sort of story. It is heavily involved with electronics and using electronics to make these custom experiences. And one question that really guides me is, how can I animate inanimate objects? When I first started with physical computing, one of the things that really blew my mind was the fact that you can embed these electronic systems within any kind of material. And then when you interact with that material, the material seems to know that it's being interacted with somehow. And that, I don't know, I just thought that was really cool. And I feel like that opened up a whole world of creative expression in a way. So that feeling is really what drives my practice. So I'm going to go over a few of the different games that I've made and how they align, how they eventually build up towards my interest in designing wearable play. So I'd like to talk first about these two games, Labyrinth and Soundblock. Labyrinth was commissioned by Now Play This and Amaze, and it integrates a variety of different materials into designing a particular play experience. So you'll notice that there are a bunch of rope on the ground, a bunch of ropes on the ground for Labyrinth. So it's hard to see in the photo, but the ropes have a blue and green color, and they have copper points on them. So when you connect the copper points of the blue and green rope, that triggers an LED on that LED matrix to turn blue. The idea behind this game is that you can connect the ropes in a way that you turn the whole matrix blue. And it's kind of just an open play experience where you weave the rope and you see what kind of patterns that you can create. And I learned that there are two types of people in this world through watching them observe this game. There are people who need to know the win condition. They need to figure out immediately, okay, what's the goal here? How can I achieve a particular design or pattern? And then there are people who are just happy to sit on the ground and play with rope, and they don't care what's happening with the matrix. So that was just an interesting view into humanity. And Off of that, I built this other experience called Soundblock for, I'm definitely not pronouncing this right, the Jocht Film Festival in Antwerp. And the idea behind this one is that you stack these cubes on top of one another, and that creates some type of stackable synth. So you stack one cube off of the other, and that triggers different notes to play. And these are stacking sculptures that it was for a youth film festival, so the children destroyed those within a week. I got sent videos of them just knocking it down. So that was definitely an exercise in learning about durability. But these works, I kind of chose to talk about them because they are heavily focused on the materials and the experience itself. There's not so much a story that they're trying to tell, but I'd say that they are very embodied games, that they focus on how you are experiencing that game within that particular space. And they are a little bit different from my typical work because the rest of my work is very narrative based. But I did like how it allowed me to focus on the material qualities and the kind of experience that those qualities afforded. So I'm going to go a bit back towards my MFA at Goldsmiths. So the first game that I made was called Void of Memory in 2018, and that was my final project for the first year. So Void of Memory has a lot going on. Basically, it's this big server that you can interact with. That's what it represents. You work as a person at the server farm who uses that server for surveillance, but there's an evil ghost that got trapped in the server. The ghost is of some girl who got lost in this town and disappeared and got consumed by the organic tech. There was a whole lore going into this. It was from 6 years ago. I can barely remember it all, but basically it was a game where I really wanted to have a strong story component. So you sit in front of this machine, you interact with it, and you experience some story that is quite deep. Now, this was my first ever proper alternative controller video game, and it showed me, it was very much a crash course on designing user interfaces and realizing that people get really put off by complex systems and that people will actually ascribe complexity to something, even when on the surface it isn't very complex. So I realized that this was actually quite difficult for people to get into and that they weren't really focusing on the story. They weren't focusing on the content on that little screen. Rather, they were focusing on the experience of interacting with this interface. So the image is obviously static, but the two little boxes in front of the main server, you were supposed to flip them and you could use that to choose yes or no questions. They had labels on them and the screen would tell you which one to flip to do what, but users couldn't really follow along with that. So I realized that in order to create a good experience, I really had to whittle all of this down. So I tried again in 2019 for my final project and created Ghost Boy in the Land of the Dead. So this game is much more simple in some ways. It involves contorting the body of a ghost and controlling his soul in the afterlife. So I made a ghost-shaped controller out of silicone rubber, which had buzzers embedded inside of it, and they would react to being bent and also when you ran into enemies within the game. And each little arm of Ghost Boy had a tilt switch inside of it, and you would bend the ghost in a particular way so that each switch would trigger a particular value, and then you could control Ghost Boy within the game. Otherwise, the game itself was kind of like a platformer. You just make the ghost avoid enemies and make him eat ghost burgers within the game, and then weird text appears on the screen talking about his existential crisis. Now, this game, although I do think I did a good job of making the mechanics a little bit simpler, the controller was really hard to use, and the game ended up being quite difficult. But I was trying to find that balance between focusing on the materials and the experience, as well as allowing people to experience a particular story within a game. So moving on to a couple of years, I don't have access to the same studio space at Goldsmiths, and my projects need to take on a little bit of smaller scale, particularly a scale that will fit into my studio, into my studio flat. And that is when I first started my foray into wearables. So I didn't have access to a 3D printer, but I did have access to polymer clay. So I wanted to create something that was kind of like a wearable badge that had some buttons and an LCD screen. And I'll be honest, I didn't really know what I was doing. I was just putting things together and seeing what happened. So I ended up making this object that I could pin to my jacket. It was about 2 to 3 pounds. It was really heavy. As far as wearable devices go, it was not good in that sense. but it did kind of work. And this idea of making a wearable object is something that continued to persist on for a few years. I also experienced with other form factors of making objects that communicated wirelessly. So to the right, I've got Camaraderie Park from 2021. And for this game, you would communicate with a Facebook bot, and you could answer questions, and based off of the questions that you answered, you would get a particular graphic show up on this device. So I was communicating with, so I was experimenting with wireless communication and whether or not I could make this kind of game that had like a virtual presence as well as a physical presence. So those were kind of my desktop experiments during that time. Now, throughout all of this entire period, although I wasn't explicitly working on wearable games, I did have wearable projects permeate my work. So this was my first ever physical computing project, these heels that I made in physical computing. So I'm a pole dancer. I've been doing it for a few years now. And if you know anything about pole dance, you know that sometimes they use those big heels. And I wanted to embed some LEDs into those. And honestly, it was a good learning experience, I'll put it that way. The LEDs themselves didn't really work. I hadn't discovered NeoPixels at the time, so I was just aligning 6 of those RGB LEDs and wondering why they kept dying. The idea with these was that when the heels turned upside down, the LEDs would change a particular color, but for some reason when they turned upside down, the other LEDs would flicker out. It was a problem, but it was yeah, my first foray into a wearable experience. And this is me testing. Honestly, while not ideal, I was happy with that experiment. I think that the shoes fell apart when I came down. So yeah, but that was my first, yeah, it was interesting that my first start into electronics was making something wearable. And also during lockdown, I got commissioned by a designer of artisanal leather bags who wanted to make something for Milan Design Week Milan Design Week 2020. And in this case, I designed a custom thin LiPo battery and the circuit where she wanted people to just put their phone in their bag and have it charged automatically through wireless charging. Now, this never really went anywhere due to lockdown, and Milan Design Week 2020 got canceled. But this was another area of wearable electronics that I had tested out. So throughout all of this, I was kind of still thinking about this idea of making a playable wearable object. And as I started to venture into the idea, I began to ask myself, what does it mean to create wearable play? And what are the benefits of wearable play? So as I was thinking about this, I sort of thought that what could make it compelling was having some sort of temporal aspect, that you carry this object with you and things happen to it over time, or depending on whether you choose to interact with it at a given time of day, something different will happen. Also, because storytelling guides a lot of my work, I wanted something that was a bit character driven, so you would interact with a character through this object, and also something that had an authored narrative. So there is a storyline that it follows along as you play with it. I also liked the idea of having collaboration and social play, where maybe you could find people who had similar devices close to you, and you could connect with them. And as I was thinking about this, I encountered the same tension that I've been encountering this whole time between designing compelling mechanics and experiences while also telling a story and making sure that people are still invested in that story as much as they are in the experience of interacting with that object. So why a wearable device? Why didn't I just stick to more installation-based work like I have in the past? But I don't know, something about making a wearable device just sounded fun. I like that it could be customizable with a particular outfit. I work with a lot of screen-based work, so the screen could be customizable and change with you. Also, it's cool that with the popularization of the ESP32 board, it's quite easy to easy to utilize Wi-Fi capabilities and Bluetooth, so you can have the device change according to various environmental factors, and you can carry the play with you. So there's always just sort of an object of comfort coming with you. I also like the idea that you could have a narrative world embedded in this very small portable object, that inside this little orb, there's just a whole world of interactivity going on. And that I found that really compelling. So as I was designing it, I was beginning to think, what would be its properties? What would make an effective form factor for this type of wearable device? So the most obvious one that comes to mind is Tamagotchi, because they're small, they're quite complex. You can do a lot. There's a good deal of interactivity, and they do have sensors that allow you to sense movement as well as a Wi-Fi connectivity. So they're quite powerful on their own. So I definitely like that they accompanied a lot of the things that I was interested in, such as the size, the temporal play, and the ability to opt into the play, even though your pet will die if you neglect it, but it's still optional. And it seems like there was this sort of reemergence of interest in tactile devices and tactile technologies and retro tech. So I don't really have the credit for this image because I found it somewhere on the internet, but people were putting together used electronics and making jewelry out of them. So I felt like I could lean into that a little bit, of making these chunky, cool wearable electronics. As I was researching this, I also delved into the world of LCD toys. So I think I was a bit too old for LCD toys when they became super popular, but I discovered this thing called Pixel Chicks, where you have this Pixel Chicks character that lives in a house, and you have these buttons that you can interact with her, but you can also put multiple Pixel Chicks together and have them come visit each other. And I was really into that mechanic. So you'll notice to the right, on the right side of these little images, there's a port. And when you connect those two ports together, the Pixel Chicks communicate with one another. And I was like, wait, let me figure out how I can get this kind of interaction for myself. I saw that they had 3 pins when you look at the port, and I was like, this is probably some sort of serial communication. If I had to guess, that's maybe an RX, a TX, and a ground pin. So I decided to take that and integrate it into my work. On top of that, I just really like the customizable nature of the screen interface, and I really like the idea that you can make these devices talk through touching. So if you put 2 devices together, they communicate with one another, and the fact that they knew that they were next to each other was just so cool to me. I know, I found that really, really fascinating and almost magical. So these were just some properties that I wanted to carry into the design of my own devices. So here's my first ever wearable iteration. It came out pretty well for a first try. I will say I used an Adafruit Teensy M4. If you know the Adafruit BMO wearable tutorial, that's the one I followed to get that. So I customized that one a little bit, but that was pretty much the basis for this design. And I tried out a few different form factors for this wearable object. So I wanted to try out some fun shapes, at least within the design stage, but practically I wanted to just get all the electronics together and see how that felt when I interacted with them. So I designed this small object. It had an on and off switch, and it had 2 capacitive touch sensors. And if you used your fingers to connect the 2 capacitive touch sensors on either side, you could trigger a new animation to happen. The content for this game wasn't that deep. It was more like a proof of concept. I designed this while at Dev Brighton. So the theme is very beachy. It's hard to see, but that's a jellyfish in the ocean on the screen. So, and I just made it animated. But these concepts sort of show what future cases could look like. So for example, with these ones on the bottom left, I designed the form factor so that way you can connect them together at the hollow end, and they'd be able to send communications. So the circular side fits into the hollow end of the other side, and you can kind of put them together that way. And same with the ones on the bottom right. They have these 2 ports that kind of stick out, and when you connect them, they're able to communicate. So that was my idea going into how I would like this object to look. And the sketch at the upper right shows ways that people could wear it. Maybe they could attach it to a belt or to a harness or maybe even to a necklace. So I was just experimenting with ways that it could be worn and then trying to put everything together to see how it actually worked in practicality. Now, off of this project, I was actually able to get a small grant to investigate it further. So I applied to phase 1 of the Interactive Futures Sustainable Fashion Challenge, which was this initiative that allowed people to research and develop ideas for making the textile industry more sustainable. So I wanted to make an LCD badge that would make sure you had good closet hygiene. So you were reusing pieces rather than buying new ones, and something that could maybe ensure that your clothing came from sustainable or ethical sources. So this is just a quick sketch of what it could look like. There could be a chain that you could attach to it. It had a small camera and an RFID reader that could gather some information about your wardrobe. It also had a TFT LCD screen that would be the badge. It would sort of be a nice wearable badge that you can attach to your outfit, and it would showcase a beautiful design. And it also had button inputs that you could use to interact with it as well for various purposes. So just some built-in room for some extra functionality depending on what you might need to do as the user. So the idea behind this concept was that it is inhabited by a spirit called a domovoi, which if you're familiar with Slavic mythology, they are like a little house spirit that watches over your house. And they would live in this badge and reward you if your project, they would reward you if your closet was good and you were practicing sustainable habits when it came to fashion, and it would reward you with gorgeous patterns on your badge. But if you shopped at Shein, then it would reward you with an ugly pattern. Yeah, for example. So that is one of the concepts, and that was, it didn't really get made into any sort of prototype. It was just an opportunity to research what this could look like. So then I built on top of my previous iteration and wanted to see, okay, what is the functionality that I would actually like it to have? So I built these two circuits where it's got the screen that displays some sort of nice pixel art. It's got I decided to settle on using the ESP32 board because it has Wi-Fi capabilities and it's quite affordable. And the modules come in all sorts of different sizes. I also gave it an accelerometer because I wanted to do something related to motion. And I also created a custom port for serial communication where you could connect two devices and they would be able to talk to one another and exchange information that way. So as you can see, this circuit is kind of messy and not exactly what I would call wearable, although it does have all of the functionality that I like. So this was sort of step one in just figuring out, okay, let's see if I can make everything work together and see if I can maybe make a structure to the content inside of this game. So that brings me now to Wearable Iteration 3, where I decided to take that functionality and put it all on a board by making a custom PCB and getting it printed. So this is very much still an iteration, still a work in progress, but I was happy to put it together and see that it all worked. The screen isn't doing anything interesting, it's just the example code, but I was just happy that I could actually upload something to it. So yay. And this is kind of where I am now at this particular phase of the project. So what's next? As I work on this, I would like to think about what sort of interactions are enjoyable with this particular form factor, what sort of stories are best suited to this particular form factor. So making sure that there's a real connection between the story content and the play experience, as well as thinking about what sort of emergent properties will result due to the form factor and collaborative play. So leaving some room to let users play with this in a way that is interesting to them. So if any of this is interesting to you, please stay in touch. These are my socials. That's my portfolio site, which I update semi-regularly. And yeah, I believe we can move on to the panel portion of this discussion. All right, thank you. Yeah. Yep. Yeah. Here we go.
I think just to give a preview of format, our plan is that we're going to have a discussion amongst the three of us about wearable techniques and oh, you made a slide. We're going to have a discussion amongst the three of us for about 30 minutes, and then we're going to open it up for a Q&A after, if that sounds good. Do we, if we sit down, we'll be in frame for the recording. Yeah, they're not streaming it, but they're gonna post it later.
All right. Okay, so we have prepared some questions that we think would relate to all of us and to the theme of this conference about open source. And so the first question that we're going to open up to this panel is how open source technology has benefited us. So how has open source technology and open source hardware and software benefited the work that you have done? Maybe I could start with Julia, because you just talked about that.
Yep, definitely. So I think that I would not have been able to make any of the things I made without open source hardware, without people providing instructions on how they made their projects, and also any of the free resources on the internet, where even if it's not explicitly open source, people describe, provide snippets of code or solutions to problems. So yeah, I don't think I would have been able to do any of this without open source technologies, because it's quite hard to reverse engineer something without fully knowing what goes into it. Yep.
Yeah, I think to just echo what Julia said, like basically wouldn't have been able to do my entire project without access to tutorials and open source and people documenting their projects, that then I was able to experiment with those techniques and develop them in my own way. It's also interesting because my background's in I've been sewing a lot longer than I've been experimenting with physical computing. And sewing is like an open source technique, like inherently. Obviously, there are some things that you can patent and make proprietary, but it is somewhat frustrating to go from that, which is a tradition where a lot of that information is accessible for free online, or it is very intuitive, to then try to integrate electronics and run into a lot of barriers to information where you can't solve a problem just by looking at it. You need someone to explain how something works or how they manage to solve a problem before you can tackle that problem yourself. And I think projects being open source is just like such a key component of keeping this field growing and interesting and innovating.
Yeah, maybe a little bit to Kay, your point about sewing being inherently open source. I think that in the sewing community, you have lots of patterns that people share. You can buy patterns as well, but you can use those patterns and do whatever you want with them. And I think that has benefited me a lot, though I've been mostly using draping techniques, and I think there's lots of videos on the internet that explain that as well. But I also have been a sewer and a seamstress for longer than I've been a technologist. And I think that the reason why I've been able to do some projects with electronics and e-textiles, because they're so good. There's excellent documentation out there on the internet that shows how to wire things. Like the simplest thing is like, how do you wire a power booster to a PCB, right? And you don't want to blow anything up because that's the only one you have. And so you go to the internet and you ask around, or you poke through forums, and in the hopes that someone has had the same problem that you've had and has vocalized it and asked the internet about it. And I think that's a very important component as well, is that we need people who ask questions. And I think the open source community is one where asking questions has been so welcomed and nurtured. And for the introverts amongst us, that's kind of nice, because that means that lots of other people have asked the same question before we did. So maybe I should bring up the next question, because that ties in very well with what we've just spoken about. So if someone were to do the same project that we did, that each one of us did, but as a first timer, how do you recommend them to get started? And maybe I could go first and then we can go around. So I think that because I integrated two disciplines together, so it's the fabrics and the sewing with electronics. And I think that it is very hard to, well, very easy to dwell in the details when you're sewing. So you want to get things right, and you want to get it on the right bias, and you want to get it on the right angle. And I think that quick and dirty prototypes are very much something that I would recommend. And if someone were to start off with something similar to what I did, I would advise them to use a servo, kind of like the cardboard prototype that I made. And cardboard is a great prototyping technique as well, and to get something working that they had wanted. So servo, a tentacle, and you don't even have to have access to your 3D printer. You can just use other kinds of materials like yogurt tub and then cut out spines from that, or use any kind of material that you have lying around and just use some normal regular thread, and you can make a prototype out of it. But as a beginner, I would recommend to start with easy materials that you're comfortable with.
Yeah, so I talked about quite a few projects, so I think I will just address two of them with this question. So for the first one, for adding LEDs into heels, don't suffer, just use NeoPixels. The library is very accessible to beginners, I think, and there are lots of resources on how to wire them to a microcontroller and how to power them. So I'd say start there, and you have a great deal of flexibility in choosing what sort of board you want to work with. Now, for the others, for anything that's related to maybe making something with an interactive LCD screen, I would say start with the Adafruit wearable pendant pixel art tutorial. It's very helpful, very cool, and there are a lot of resources. It's well explained, I think, to show you how to get started with maybe making cool animations on an LCD screen.
Yeah, I think my answer is pretty similar to both of yours, which is just jump in and start prototyping. I remember specifically I had a lot of frustration trying to track down a tutorial on just how one would go about assembling your own LED grid, which is like not a complex wiring system, but I just could not find documentation that made it really clear how it would work for someone who was a complete novice to this. And I tried to follow many extremely complex schematics before I finally found a tutorial that was like, oh, you just connect the grounds and the powers in rows and columns. That's essentially all it is. So prototype early, prototype often. And yeah, I think also some of what Julia was saying about like pre-existing tutorials, like if you can find a tutorial for a similar project, start there, just build even that exact thing. And then once you've got a basic understanding of how the tech works together, then you can iterate on that and adapt it in the ways that you would like to for your project.
Just to add one more thing to that is that kind of like to both of your points, there are components out there that are sold by very obscure websites that have very poor documentation. So you're much better off buying components or getting components from recognized platforms like Adafruit and Pimoroni and PyHot or whatever alternative there is in your country. And because those usually come with really good documentation, like even on the product page. And that has been kind of like a lifesaver, because I do have some of these obscure components in my drawer somewhere and I don't know how to wire them, or I figure it out by myself through trial and error through like long periods of time. And so if you're beginning and starting out with these things, look for products that are sold by trustable companies and organizations.
Yeah, and so the sort of last component of this series is what barriers to access are there specifically for designing wearables for people who have a fashion interest or experience when it comes to interfacing with hardware? So if you're coming from a soft materials background in fashion or design, what are the barriers to access for integrating hardware with that?
I think that it's just something very simple is the rotation of your electronics. So for example, the dress that I worked with, I designed it horizontally, so flat on the table, everything worked. And then the minute you put it up, you have to think about, oh, some of these spines are going to bend because like there is some weight that is going to, gravity will pull them down and whatnot. And so there's just so much that you haven't thought of when you prototype something or make something that is like a flat. And so with a lot of wearables, it has to be sturdy and it has to be resistant to, you know, like sudden movements or just like normal movements. Like you want to make something wearable, which means it has to be movable, it has to be breathable, it has to be usable, and it shouldn't snag at the easiest, you know, at the easiest movement. And so that is, I think, one of the greatest barriers to entry is like recognizing that to move from one discipline to another or combining them, you have to respect both the both fields almost, and understand what the limitations and affordances are of those both fields.
Yeah, so I think going off of what you said, for me, the hardest part or the biggest barrier to entry is making the functionality that you want fit a form factor that aligns well with being worn. So how do you fit all of these complex electronics in something relatively small that will not light on fire like it has for me a few times? So I think it's a lot of trial and error and just seeing which shapes work best.
Yeah, and you know, I think a real barrier to entry, right, is wearables specifically are a branch of physical computing that require you to combine so many different fields at once. So you have to not only understand how your soft materials work, so be a sewist or a pattern maker, have like some comfort with that. You have to understand physical computing. You have to understand, I think all three of us designed our own circuit boards. So you're doing circuit board design now. Julia, it looked like you were designing your own graphics for your games. You have to be an engineer to understand how the tension of your thread is going to interact with your garment once things start moving around. It's really so many different categories of knowledge that you have to have a base in or a level of expertise in. And as you go, you're often realizing like, oh my gosh, this is like an engineering problem that I'm trying to solve. And I'm not an engineer, I'm a fashion designer, or I'm a physical computing teacher. And it's really difficult to combine all of those. It's a lot of information to hold in your head. And I also think many of those different areas of knowledge are like pretty aggressively gendered. So, you know, fashion and such is especially in the West, like a very feminine pursuit. You know, men are not encouraged to go into that. Obviously, there are exceptions and there are people like crossing these boundaries every day. And then also vice versa with tech, like women are not encouraged to go into tech. There's a lot of barriers to entry just for having, you know, access to that and encouragement and mentors and people who are willing to help tutor you over the initial learning curves on both sides. So having people that have both of those knowledge bases as well as like how to combine them is like pretty unusual. It's quite rare. Yeah. Should we, I feel like that actually segues into our next one, which was we wanted to talk a little bit about the ways that we've blended technology with other disciplines. I feel like I sort of answered that on my own, but if the two of you would like to answer also.
Yeah, I think it's sort of hard for me to say because I started with a tech background pretty early on. So, I mean, I've been coding for almost 10 years now, which is insane when I think about it. No, more than 10 years. But yeah, so code has always sort of been there with me, but before that, I wanted to be an illustrator and a comic book artist. So I try to integrate illustrations and animation within my artwork. So I do a lot of small screen-based media that showcases those. So actually getting animations and graphics to work with these types of screens, which were not designed for that. They're often designed to give you some sort of insight into whatever sensor you're working with. So the libraries that go with these screens often have that in mind. So how can you quickly show readings from your sensors? If you need some sort of interface that tells you how your tech is doing, you can do that. But if you want to move sprites quickly or showcase anything more complex, it gets a little bit more difficult and you have to try to find and make it work for you. So I think that's probably where the biggest intersection happens for me.
Yeah, I think I also kind of touched on this when talking about the dress and incorporating textiles and fabrics and fashion with technology and electronics. I think those are the two main disciplines that I combined. And there's a lot of figuring out from both, because the minute you combine them, things look different. Like, so how do you make sure that the fabric holds the components that you need, and do you need to print pieces for that, which I ended up figuring out. But it's like, how do you make that bridge is, I think, a very important thing. I think another, like how I combined another discipline, I think just those two, so electronics and textiles are the ones that I combined. And I think a very important part is also a little bit before I mentioned about the affordances and limitations of both disciplines that you're working with. So for example, if you're working with servos, you have to understand like the torque that servos can pull and the power that they require, and like kind of like deep diving into the electronics part of the things that you're using, and like having a good understanding so that you could build that bridge into the project that you're building with another discipline in mind.
Yeah, I'd say that segues pretty well into our third question of, do you use a technology first or material first approach? So would you like to answer first?
Yeah, so I think I use I think because I'm so comfortable with the fabrics and the textiles, that I've decided to go with technology first, because I know that that's going to take me more time, and that I can figure out the textiles part later, and that doing the electronics means that I have a really good understanding, and because I already understand the textiles field so well, it's very easy for me to integrate it. But I think before, and especially with the Blooming Dress 1.0, I took a textile first approach, so materials first approach, where I spend most of my time making the corset and prototyping and like having some kind of trial version working. But that just looked good. And then I figured out all the tech and all the electronics, and that kind of put me in a very stressful situation, because I didn't really know the electronics part so well as I did the fashion and the textile part. And so I've now decided to switch that and start with something that I'm not so comfortable with, or not so, I mean, now I'm comfortable with it, but that's not super intuitive to me.
Yeah, I think very similarly, because I am more comfortable with the textile element, I tend to start with tech. And I also think very similar to what Rehana just said, I have arrived there through trial and error. I definitely don't think, I think my initial projects, I tended to start more with materials and then try to sort of squeeze the technology into it. And I think after several rounds of different projects where that is just really difficult, and also, you know, it tends to cause me more problems, I would rather now start with the technology, get a prototype working, figure that out, and then from there figure out how to integrate that into the knowledge and experience I already have with whatever wearable form factor I'm trying to fit it into.
Yeah. So for me, I first start usually with what would I like to say, or what kind of story I would like to tell. And then I think about what tech will allow me to do that. And then I think about what form factor is also best for that overall story. And then I begin to see how I can integrate the tech with that form factor. And it's kind of a process for me that works side by side through many different phases of iteration. So I'll try one type of enclosure or one type of shape, and then make the electronics fit that and see what works best.
Okay, that takes us to another question that we all three of us kind of really hope that we would have time to answer it. And it's about the creative process around our project and how we got to where we are. And I think we all touched upon it a little bit, maybe a little bit more than the others. But if you could talk us through your creative process in creating your project. Someone like to go first?
So since I do a lot of like freelance costume commission work, I very often start with a Pinterest board. I'm a visual person, and really for me, it's just collecting a whole bunch of visual inspiration for a project is my first step. So references, whether that's existing fashion or photographs or aesthetics, I very often try to pull from vintage and historical costuming, imagery, stuff like that, because I think that tends to make stuff look more unique than if I'm just pulling from, contemporary like internet imagery. I make a big old pile of JPEGs is step one, and then I do a sketch. And then from there, I tend to, as I was kind of talking about like technology or materials first, then it's tech time, experiment, like what are the limitations of the technology that I'm trying to use? Like, do I have to add or remove any features that I was hoping to incorporate? How big of a power source do I need? And how is that going to affect the overall design? And then from there, it's a lot of like being adaptable as I go.
For me, it's a little bit hard to articulate sometimes when my process starts exactly, but usually what I try to do is I try to recreate a particular feeling or have that feeling guide my process as I go. So first I try to reflect the feeling within the particular interaction, and then I'll start diving into the text to maybe see whether or not that interaction is achievable. And then I basically start developing that interaction. So will it have a particular content? Will it be more complex, less complex? And what kind of, I guess, materials or trimmings will make that interaction really salient towards the user? Now, I don't always know if that particular feeling is conveyed in the end towards the artwork, but it's there throughout my entire process, at least as I'm working on it. And it's definitely the impetus for me to start working on something.
Yeah, I think both of you have a very interesting way of looking at pictures and then feelings. I think I look more like I focus more on colors, just like looking at colors, and because I had thought about the movement that I wanted to create, but what was very important for me is how do I use colors to really exemplify the movement, but also what kind of colors would make sense to incorporate. And I also did a whole I looked for images, I looked for interest, but colors were the thing that guided me most, I think. And then I looked for themes as well. So I was trying to go for something more galaxy. And then I thought maybe something like sea creatures. I tried to prototype a jellyfish, by the way, with like S-shaped, like curly tentacles. But then I made them out of cardboard, and it turned out you need so much more like rotation and spinning of the servo. So you would need to spin them at a much larger distance to really get some movement to show, because you would have to pull through so many different parts of the tentacle. And so colors really guided me, pictures, and I just thought about the kind of movement that I wanted to achieve.
So that's the end of our questions, I think. Do we have one more? We can do question Z, or should we open it up to questions from the audience? Okay, so in that case, let's move on with our final question. So what do you wish someone would ask about your work, but you've never been asked about? Who would like to start?
I think maybe it's a question that I ask myself: is what other discipline can I integrate into these wearable tech projects? But I think what I would really like, what something is that I would like someone to ask me is, I think I'm really passionate about sewing itself and about molding fabrics to the body. And like I work with the female silhouette a lot, and so you have lots of curves, and like how do you curve fabric in a way that respects the body and and kind of adores it and accentuates it. And I think that's been something that I've been trying to do, using mannequins and using patterns and creating all these like bodices to kind of make those shapes that I'm so passionate about in achieving. And there's so many artists that do an impeccable job, like Zach Posen and Iris Van Herpen, and they all respect the silhouette and the body in such a way that is for hours about it. And so I think that's something that I don't ask that I don't get asked about quite often is how do we create those shapes and those silhouettes that respect the wearer.
Yeah, for me, I often get asked, like, how did you make that? What library did you use? What programming language did you use? But no one ever asks me about the characters or the world or the story that I'm trying to say, and I wish I got more questions related to that.
I have a question I would like people to stop asking me, which is, will you make me chaps? I've made 4 pairs of assless chaps in the last year. It's too many. I don't want to do them anymore. I'm joking. They're quite fun. It's pants with the hard part removed, so it's not that bad. I think something that I would love to get to talk more about is, so because I make costumes for drag and because most of my clients are queer, I have to do a lot of pretty careful consideration around like dysphoria and the gender of the gender and the gender presentation of like the costumes that I design. And that's so deeply individual for literally every person that I work with. So like what might be very affirming for some people is like really not affirming for others. And it also is like very dependent on the specific mood of the piece that I'm making. So I guess there's not like a broad way for me to answer that, but that is like a thing that I'm really interested in. And I think it's also something that I would like, I'd love to have like more even sewing resources available for like tailoring and designing techniques that are about like highlighting certain parts of the body or de-emphasizing certain parts of the body, which is a thing that I have like, I think is niche enough that it's a little tricky to find. So like, how do you design, I think specifically when you're sewing, you use a pattern block is the terminology for the like very basic template you use to make tops and bottoms. And most often the tutorials that you can find readily accessible online for pattern blocks for tops include tailoring for a bust line. So they're made to emphasize a body with breasts. And then I have a lot of clients who don't want that to be emphasized. And it's actually really tricky to then adapt a pattern on the fly that you know, fits a body that someone doesn't want that part of it to be emphasized. So anyway, I think that's a really interesting field. I would love to have like more resources and more people to like discuss and consider that element of it. Oh, that was great. I would love some tailoring resources. Should we move to opening it up to questions? Does that sound good? I guess just put your hand up if you've got something you want to ask any of us. Priyanka, do you mind ferrying the mic around? Thank you.
Questions? You got one?
What's your interaction with the engineering community? Because you almost haven't mentioned any, let's say, engineering community, right? So there's plenty of engineers who are not really in the fashion, but they would love to brainstorm, help you brainstorm and find the solutions. Do you have some feedback from the community like that?
I don't think any of the 3 of us have engineering backgrounds, right? Unless I'm misunderstanding. I would love crossover with the engineering community. So if you have resources or places that I should look or ask, I would love to hear. Just Reddit, get on Reddit. I would actually love to do more of that because I think it would be helpful.
I think that's one of the parts what makes it such a welcoming community is that people are so willing to help. And I think that while I haven't asked questions on Reddit, for example, or on any forums because they were already answered, I do have I have a big community of people who are engineers who I can go to ask these questions to. So I appreciate them all very much. Because if I have any question, I would go to the people who are the experts in the electronics or whatever it is that I have a question about. And I think the in-person community around me is already quite substantial in helping me answer those questions. But thank you for reminding us about that there is a very willing community out there as well to help.
Yeah, so I interact with engineers quite a bit. In some ways, my background, I've taken a lot of engineering and traditional computer science courses throughout my experience, and I'm currently a lecturer at an electronic engineering department. So it's not, it's very much a traditional electronic engineering type of school. And oftentimes I have the opposite issue where I'm teaching electronic engineers to be creative. Not that they're not already creative, but in a different kind of sense of, the thing that you're making doesn't need to be traditionally functional. You can think outside the box and try to express yourself through this. So helping them lean into that is one of the things that I'm trying to do. But in terms of community, I don't really go to Reddit, but I do go to a lot of Discord groups that are related to hardware hacking and that sort of thing. I also do know a lot of engineers through my career, and I often definitely bug them for help, for sure. Is there anyone else?
Oh, yeah, I got one. Yes, hello. How do you feel the direction of wearable tech will go in the future as just technology as a whole just keeps evolving and more things are being introduced?
That's a very good question. I think I should have said that question. I don't really usually get is where I think, where I see wearable technology is evolving in the future. I think it's in some ways, so I'm very excited about all the fashion, the wearable fashion or wearable tech fashion projects that are out there and that I keep on expanding, like the ones that I showed on the slides. But I do have a sense that most wearable technology projects or products are usually geared towards health monitoring. So a lot of them are Fitbits and designing wearable tech that way, that ultimately benefit big corporations or that are rolled out by big corporations. And I think that's usually the case when you're working with technologies that are very fiddly to really do on a large scale by yourself, or that are accessible enough for people to go on to make them, to do them themselves. And so people will just go on and buy those products. So I would love for the wearable tech community to keep expanding in the way that it has been, and maybe open sourcing more of the projects. But that I do think that most wearable tech projects will keep evolving towards the big corporations, unfortunately.
Yeah, I think that the tools used to make wearable fashion will become more affordable and better documented and more accessible in that sense. I also think that we're seeing a lot of people, I guess, emerge in the space, playing around with it and using it for more explicitly creative purposes. Yeah, from a corporate standpoint, I do see them being more used for health monitoring, but also in more intrusive means, I think, in the future, unfortunately. But I do think that more people are going to find a way to DIY them and make them more personalized.
And that's the open source community.
Yeah, definitely.
And that's the open source community, which will keep on doing those projects, like you said.
I've also definitely in the last couple of years, I think as things become more affordable and smaller, seen a real expansion in wearable tech for festival use. There's a couple of companies now selling a variety of LED products that are meant to be taken to things like Burning Man, Bonnaroo, music festivals that people really want to have a dramatic outfit at. Not to rag on any of those companies, but I would love to see more people empowered to build their own punk DIY self created versions of these projects, because at the end of the day, like LEDs are a pretty accessible starting point. And you could pay a company to give you an LED wristband or headband or whatever, or you could pretty affordably, actually for about half the price of what a lot of these are, you could build one and make it much more custom. So that is a market that I'm seeing expand. And again, I'm like very specifically in drag, but I'm seeing a lot more drag people integrate electronics. Again, I think because similarly to red carpet, also like all of these spaces where you want like one really dramatic, impactful moment, there is definitely kind of an expansion in that direction with fashion. So, Met Gala moments, a lot more people are like taking stuff onto the entire Drag Race enterprise with integrated electronics in it and stuff like that. More questions?
Yeah, just quickly want to say that was really, really wonderful talks from all three of you. I thought all your work looks absolutely fantastic, and I'll definitely be sharing it. So I work at the College of Art at Edinburgh, and we have textiles and performance costume students coming through, a lot of whom I think you've touched on a bit, can be quite hesitant to include sort of digital tech and hardware into their work. I was just wondering if you maybe had any advice for young designers coming through who maybe want to get over that initial fear of this massive sort of space of open source hardware.
Yeah, I think I would say, and I kind of said this in one of our other questions, but finding existing project tutorials that are out there through open source hardware, or Adafruit has an incredible library of really easy to follow tutorials. Just building one of those basically exactly so that you learn the basics of, how to make a circuit, how to like turn, the circuit playground off and on. There is definitely, once you dive in a little bit, more materials, I think, being created for people who are just starting out in electronics. Like I've used the Circuit Playground for a couple of workshops, and I find that specifically to be a board that's like very beginner friendly. So yeah, look for existing open source tutorials and resources. And don't be afraid to reach out on forums and to people who are already like integrated in the community. Like I would be like I actually really like to send people resources. I've had a couple of folks reach out, and I'm more than happy to send you a way too long email or DM with a list of links in it. And I have found that a lot of people are really generous with their time and energy and resources for helping people get started.
Yeah, I would say that there's no way to really get over the fear other than just by doing it. So I would say they should first define what they would actually like to make. So what are they making, and why does embedding technology within that object benefit it? And then beginning a search for something that would give them the MVP of that. Like they should definitely have a goal idea in mind of the thing that they would like to create, but then what is the smallest, easiest proof of concept that they could make to showcase that idea? And then once they've defined that, I would say they should begin finding sources online, all sorts of forums, but also companies like Adafruit have an excellent Learn section dedicated to their projects, as well as Pimoroni does too. So those would be my two main ones to get started with.
I think LEDs are a very good way to start with embedding electronics in garments. But also like the resources that both Julia and Kay already mentioned. I think the question that you asked though could be asked for any discipline. So I think that a lot of students, especially students and of all ages, when they're trying to learn something new, there's quite a high barrier to entry, or they feel it that way. And I think that our job as educators is more to give them the tools. So what I mean with that is to give them enough experiences with different components, very introductory maybe, but like an experience with sewing an LED onto a garment with like a little coin cell battery and sewable and conductive thread. Maybe using the video that I linked in my presentation about the Kinetics Wearable toolkit that is completely open sourced. It's super high quality. All the files are on the GitHub page. as well. And they have a really good video demonstrating how you can incorporate servos into garments. And so everything is there already. You just have to print them and assemble it and code it. And all the steps are there already. But I think the job for, as educators, our job is to give them as many rich experiences with different components, and then tell them, okay, now you got all the tools, you've tried all of them, now let your creativity loose, and depending on what you want to do with it, go and do your own thing. And as the earlier question about community was, I think there are lots of communities that you can reach out to, but also Adafruit has such good documentation. Like, I think this is the third time that we're saying it, but they have really good documentation, and so do some other platforms as well, like Pimoroni.
I have one more thing to add to that, which is just accept that your first prototype is going to be really goofy. You're going to be lucky if it turns on for 20 minutes. Like, it's going to look so borked. And the second version is going to be the one that's a lot closer to what you want. But, you know, it's a learning experience. Like, just don't get frustrated when, you know, your first thing looks crazy and barely turns on, because you've learned a lot in that experience.
Yeah, I just wanted to add on top of that, that failure is part of the process. Failure is the norm, at least for a good portion of the time. So yeah, they should just get used to that and build in a lot of time for prototyping and trying different things, because that's really the only way to do it. Are there any additional questions? Yeah.
Is there maybe a tool that you are missing, or a tool that you're like really frustrated with that you would like it to be improved, that would help you tremendously in your work?
A few. So the first one is the LCD screen libraries. As a matter of fact, I had a whole 5-minute hyper talk at Amaze ranting about the ones rating these screens from 1 to 10 on how awful they are to work with. So the libraries could definitely be better and be more flexible and have game designers in mind, with clear guidelines on how you can animate sprites, make them recognize each other. So a better framework for that would be really helpful. Another one I'd say is with routing on PCBs. So I've tried making a few more complex ones, and you have to route everything yourself, which, you know, we're trying to integrate artificial intelligence into everything. That sounds like a great optimization problem for artificial intelligence to do. So maybe we should just have it do that. But that is probably one of my biggest things, right? I just wish that we had better, better resources for that, I think.
Yeah, I think, but this is like such a luxury problem. And I think that if you enjoy the process of doing something, then you wouldn't object. But I think what I think is missing is like simulators or virtual simulators. So if you're working with, and this is like very specific to what I worked on with fabrics, is okay, how will this look like if I attached it to this kind of servo versus that kind of servo? What if there's this much weight on it versus that much weight? How about if it's vertical versus horizontal? And so like kind of like a simulator of the real world of how fabrics with electronics will interact. I think that's missing. But again, it's like such a luxury problem. And if you enjoy it enough, then you would have no problem trying it yourself. But it's just like the minute from thinking about it to actually putting it in reality and prototyping is sometimes so long, where you've spent so much time trying to get to this point and then it doesn't work. And I think that could be streamlined by these simulators. Yeah.
This isn't really totally missing, but I think a problem that I run into a lot is or that I could use more of, is documentation that is written with absolute beginners in mind. I think too often I'll jump into documentation of a project and it's using some sort of like language around components or techniques that like I just have zero idea what is going on there. And, you know, now a couple years into learning about electronics and physical computing, I have like a much better sense of it. But especially early on, I think that is a thing that scares off a lot of beginners, because it's like, I have no idea what a capacitor is. I have no idea, like, is this something I can leave out of the circuit, or is it something that has to be there? Like stuff like that. And, you know, just like we all love to like throw around the shorthand terms for everything, because a lot of these things have really long names. But I think just keeping in mind when you're writing documentation for projects that like if someone who's a total outsider reads this, like, do you have enough information for them to be able to figure it out? I think we do. Any more questions? I feel like we've got about 5 minutes left, I think.
Sometimes I have a question. I'm just curious. So all of you talked about how important open source and documentation was, especially as you were getting started. And now that you are in a place where you are speaking on a panel and you are creating amazing things that you are documenting, I wonder if your relationship to like documentation and the process of documentation and using documentation has changed at all.
I don't know that it's, I'm trying to think. I definitely, once I went to school, because like the first couple projects that I was just doing on my own are basically not documented. So like that wig thing that I made, like I don't even know that I could recreate it if I want. I think the code is like lost somewhere on my computer. If that thing ever has problems, I'm starting again from scratch. So I guess like over the course of this, like documentation for myself, because, you know, I'm realizing that like, I'm not going to remember how I assembled something even 4 or 5 months later. And then kind of what I was just speaking about in terms of like writing stuff for absolute beginners, I think that accessibility has become very important to me as I've had to sort of like slog through stuff that I could barely understand. And also just the good documentation takes a really long time, and it's worth doing, but it takes a long time.
Yeah, documentation is definitely one of the hardest parts of a project, explaining how you did it and thoroughly enough so that someone else can understand. I feel like sometimes with my own personal projects, I want them to reach a particular point before I want to document them or feel like it's worth sharing, which I feel like it's not necessarily the best attitude, because I think any kind of learning experience is valuable. But making things and reading through tons of my own documentation has definitely affected how I approach my students and how I explain things from absolute zero, because for a lot of them, you really can't assume that they know everything, even if they may have some experience. So definitely thinking of all the things that someone who has never seen this before, what would they be missing, and just challenging your own assumptions a little bit of just, you know, I've been doing this for so long that I forget the things that I'm taking for granted sometimes. So just reassessing that and thinking of but thinking of myself at my starting point and seeing like what would have scared me off then and what would have not made sense to me then, and making sure that I discuss it or clarify it within my own lectures.
I think that's a very good question, and I think there's a difference between process and documentation, and I think what you see on social media a lot is process videos, and it's like this super cool looking project. Someone makes a 30-second video out of it and how they did it, and it's like super fast tracked, and it's like you don't get all the steps. And I tend to avoid that. I think that's not really documentation. I think documentation is something that I properly learned during, like when I was at MIT, during that class that I took, where if you didn't document it, it didn't happen. And so you had to have documentation with it. You were picked on at random during class every week to explain how you did it. And if you have like a super high workload already from other courses that you're taking, then you need to have a track record somewhere of what you're doing. And so pictures is what you need to have. Picture everything, and then you have like a memory around that picture. And then as fast as you can, you should document it and write it out. And I totally agree that good documentation takes time, but it's worth it. And so I usually have an imaginary person in my head who I'm writing for. So if this person were to do my project, how would they want me to describe this if I didn't know what a capacitor was, for example? Or if they had no idea about PCBs, and how could I explain it in a way that is so accessible that this imaginary person in my head who has no idea about all these things could still do it. But good documentation has a lot of, just accessible language, good language. And I also tend to take a lot of pictures. Like my gallery right now is just full of pictures of failed 3D printed parts and and whatnot. And I think that's also part of documentation, is showing what failed. And I think that, for example, today's presentation, I didn't show a lot of what failed, but a lot has failed. But good documentation shows that, so that whoever is trying to replicate the project could avoid those pitfalls as well.
I think just to add on to that very briefly, I really got into the habit of turning on my camera every single time I was testing anything, in case that was the only time that it worked. Which also means that I've got some really incredibly hilarious footage of like me flipping a switch on a wearable, and then like you can see my face going, as it like actually functions for the first time, which is also just kind of a hilarious memory to have. I think we're at time. Thank you all so much for sitting here for 2 hours. This was a long one. We really appreciate it. Do either of you want to say anything to wrap up, or?
Thank you.
Yeah, I think if you're looking for resources, I think all three of us already mentioned that we're open to having people email us or getting in touch. So if you do have questions, if you do like to get something working, you don't know how, or your students need some help, please do get in touch. I think we between the three of us, we have a wealth of resources that we could share, as well as in like individual wisdom, if you may call it. But yeah, thank you all so much for coming.